Good morning.
Morning.
Do you remember when we started this course, we started with a picture which was very familiar to you. It was like this. And I asked you whether you know what this means. And then we figured out that you sort of know what it means, but you sort of don't know what it means either, because you don't really know where these things come from, where does demand come from, where does supply come from. And so that was that's how we started our journey, right? And we started by talking about demand and trying to get to understanding where demand comes from. So now we know how consumers make their decisions. We have the model for consumer choice. You understand that. The next step is to go from there to the demand curve, to understand how that gets us to the demand curve, and that's what we are doing today, essentially. We'll do some other things too, but fundamentally we want to understand how we go from consumer choice, which you understand now, to demand. And we'll do that graphically, and we'll do it algebraically as well, just as we always do, and we'll try to think about these questions intuitively as well. So, more specifically, first question, what happens when you change price or income? Then how does that help us go from choice to demand? The law of demand, do you know what the law of demand is? Does anyone know? Yeah, Ryan, what is the law of demand?
When price goes up, client demand goes down.
Okay, yeah, exactly. That's what we think of as the law of demand. So we'll think about that. You know, is that really a law? Can we prove it if it's a law? What kind of law is it? And then we'll think about, that will actually prompt us to think about analyzing further what happens when price changes and the consumer changes her optimal choice. Okay, finally, if we have a little time, we'll talk about elasticities, which is basically review. I know you've studied elasticities before. I'm assuming you've studied elasticities before in intro. But now, with the tools we have now, we actually have a somewhat simpler way to think about elasticities. So, and elasticity, of course, reflects the sensitivity of demand to some variable. So once we start talking about demand, that's kind of a natural next question. How sensitive is it to price or income? Okay. So let's start with price changes. I left some of this blank for you so that you can fill it in. So in this picture, we go from this situation to this situation. My first question to you is, what happens between those two? So the price of, fill in the blank. Everyone, come on. The price of X, yes, goes up. Right? Yes? Okay. And as a result, this consumer changes her choice from this to this. So I know it doesn't look like it, but I meant to keep the preferences the same between the two pictures. So the indifference map should be the same. We are assuming that the same preferences hold in both pictures, but the price of X goes up. So that means the demand, should never even, the budget line pivots, right? Like that. Okay. As a result, this consumer consumes more or less of X. So less of X and more or less of Y. Okay. I'd like you to continue that sentence and try to explain why.
How you can know more Y?
Well, can't you see?
No, I can understand for the more X, but Y never changed.
So the question is, how do you know that you consume more of Y, right?
Yeah.
But you see in the picture that you consume more of Y, right? Do you? So if I were to show the consumption bundle before the price change, it would be like that. And after the price change, it would be like that. Okay, so this is, you could say, this is Y1, and this is Y2. And I think it's pretty clear from the picture that Y2 would be larger than Y1.
But maybe it's possible about, definitely we also can know about the less we lost more, right? So we can also hypothesize, maybe this guy's hit X more, so which means he more prefer lose 1X I don't know how to plan about that part.
I think from what we can tell from this picture clearly is that x2 is less than x1,
Yeah.
and y2 is more than y1, right?
Yeah.
Maybe you're saying it wouldn't have to be that way.
Mm-hmm.
I don't know. If preferences were different, maybe it wouldn't have to be that way. With these preferences, the way I drew this, that would be true. But my question is why? So this consumer, as a result of this price change, consumes less of X and more of Y because, explain.
To each other?
No, just answer, yeah, to the whole class. Yeah, thanks for asking.
So,
yeah.
Because when the price of X goes 1, he has to give up more Y for an equivalent number of X or whatever his happiness or utility is. So now, because the budget constraint is tighter, it shifts.
What do you mean by tighter?
It's closer to 0, so he can spend less, and it's more steep in a sense. So now the marginal value of Y is higher.
Okay, those are very good points. Maybe we can put it even a little more precisely or succinctly, but that's very good. So I think you're on the right track here. Can anyone maybe make that a little more succinct and maybe use some terms that we already know for this stuff, although you use marginal value, which is good. Dan?
So it looks by your picture there that the price of X increased. Therefore, we have less income if we're buying the same. If we want to buy sort of the same ratio, I don't even know about that, but like if the basket that we have less resources to spend on X than we did with. Sorry, this is poorly found out.
Okay, so that's okay. Bjorn?
The price of Y relative to X went down, and so it's cheaper to buy Y to get to a certain utility than to buy X, and so the ratio is going to shift in that direction.
So a point that you're making that I think Kazuma made implicitly maybe is that what we are interested in is relative prices. That's what really matters, right? Did you notice that from the homework you did for today? That was meant to get you to think about that too. Only relative prices matter. And the price of X goes up and the price of Y stays the same in nominal terms. So relatively, Y became cheaper, X became more expensive. Can you say that in terms of opportunity cost? How would you say that using opportunity cost?
Opportunity cost of X is now, it's now more Y, I guess.
Yeah, the opportunity cost is higher.
Yeah.
Right? Okay, so that's our intuition for why this is true, right? Why this price increase leads to this. Let's be really precise. So this increase in the price of X leads to a decrease in consumption of X. Does that sound like anything you've heard before? Like what? Yeah. So that's what we talked about at the beginning of class, right? So this sounds like the law of demand, right? Okay, well, we'll get back to it. Now, let me ask you a different question, a somewhat different question, different problem. What happens if instead of a price change, we have a change in income? So the consumer goes from this level of income to this level of income, and therefore from this optimal choice to this optimal choice. As a result, this consumer will consume more or less of X. More of X and more or less of Y. Okay. That seems clear from the picture. Intuitively, again, why? So because... Yeah, Ryan? You could say it that way. He can afford more. Okay. How else might you explain that? I want you to explain that. By the way, is this obvious? I mean, is this completely obvious? If you say this consumer's income goes up and therefore he's going to consume more of both goods. Is that just completely obvious? It's difficult to explain because it's so obvious?
Yeah.
Yes?
It is. It's like completely obvious, but it's
about
like
the income in another ways can show us about how much value for each customer. If the income is higher, which means about their value for the goods will be higher. Does that make sense?
So income is about opportunity. Value is utility, right? And those are different things. And we should keep them apart because that's pretty important for our model, right? Even if you think about mathematically, we are maximizing utility subject to constraints. Income is in the constraint, value is in the utility. Yeah. Finita? I'm sorry, can you speak up a little bit?
Do we assume that all of the income is spent?
Are we assuming that? I'm not assuming it, but it appears to be the case, right? So I'm not saying a priori that it has to be spent, but if you look at these preferences, and I didn't show the direction of preference because this is the what we call the usual or regular kinds of preferences, but it's going up this way. So yeah, it's all spent because why? What's the word? Because these preferences are monotonic. Yes. So income is spent. That's true. But do you completely agree? All of you agree. All 43 of you agree completely that this is the most obvious thing. Could it ever happen that you increase income and your consumption of some good goes down? What do you think?
That could happen if the good is inferior.
If the good is inferior?
Yeah.
What's an inferior good?
It's like a good that you get only because your income is like lower. It's like what you could afford at the time.
So give us an example of some good that you might think of as an inferior good.
Like spam.
Like spam. Okay, so you might imagine that you consume a certain amount of spam, and then your income goes up, and then you consume less spam, right? So that wouldn't be true in that case. I mean, if X were spam and Y were everything else, or I don't know. Yeah.
So they could both be normal goods then.
So in this case, can we say that they're both normal goods? Yeah, it looks like. They're both what we call normal goods, Dan.
In the case of inferior goods, like she was talking about, would it then the indifference curves then like shift more toward the other product then?
Yeah, exactly. That's a good point. So the indifference curves would look different. The indifference map wouldn't be like this. Preferences would be different, and this new optimal point wouldn't be here. It would be more somewhere up here, probably, right? Okay, but it may seem like we're spending a lot of time on this, but I just like to point out that you all agreed just now that it's completely obvious that consumption of all goods will go up as you increase income, and now we know that's not true, right? So if you have inferior goods, and by inferior we mean something really specific. We don't mean like that's a low quality good. We mean something really specific, and what we mean is just exactly this. If you increase income, you might consume less of that good. That would be an inferior good. So we'll talk more about this, but I'm saying the intuitive explanation here is maybe not completely intuitive, right? So maybe you can say that for both of these explanations, actually. The intuitive explanation we came up with is essentially, and Kazuma, you pretty much started us off on this right away. If X becomes relatively more expensive, if the price of X goes up, the consumer will substitute Y for X, right? Because it's relatively cheaper, the opportunity cost of X is higher, so that's intuitive. With the income change, if the consumer has higher income, then he will consume more of everything. That was our intuitive explanation, but maybe it's not 100% intuitive. So by the end of this class, hopefully we'll be in a better position to talk intelligently about what might or might not happen with a price change like that, and why that intuition may or may not be right. And that's really one of the reasons why we use models in economics, why we use mathematical models, precise models, because we have intuition, and sometimes our intuition is wrong. So when we use precise models, we can either say, look, I've proven it mathematically however, and my intuition was right. Or we can say my intuition was sometimes right, and now I know exactly when it's not right, which is really, really useful. Did you have a question, Dan?
Yeah, would it make a difference for us to say with these ceteris paribus? Because like
Okay, so you brought up the ceteris paribus thing, which means other things being equal, right? Which we haven't talked about in this course yet, but I'm glad you brought it up, because when we talk about these questions like, the price change up here, or the income change here, we are assuming that everything else is equal, right? So we are always assuming that when we look at some analysis like this, other things that might be relevant are not changing at the same time. Yeah. Okay. So now that we know a little bit more about price changes, let's take a look at what happens when you change price, when you vary price a lot. So by a lot, I mean you change from one price to another price to another price to another price. Why do you think we would do that? Sorry, that's what I'm doing right here. Right here. Why are we going to do that? Yeah.
Say that again?
Why do you think we are going to do this, where we just change price from, let's give these names, maybe that will help. So this is a budget constraint that has a certain price of X. We'll call it PX1. Okay. This is a budget constraint that has a different price for X. We'll say that's PX2. And this budget constraint has yet a third price for X. By the way, what can we say about the relationship between these? PX1 is less than or greater than PX2.
It's more or less. The price of X is less.
Yeah, so the price of X went up from P1 to P2 and then to P3. Okay. So why would we be interested in looking at how your consumption varies as you change the price of X, let's say from 1 to 2 to 3 and maybe to all kinds of other prices? Yeah.
It could show us the shape of somebody's indifference curves.
It wouldn't be somebody's indifference curves. We are using that actually. So the indifference curves are here. They are already in the picture, right? So we take that as given.
Oh, I see what you're
Okay.
saying. Okay, yeah.
Yeah, why might we do that?
We just show the value that we have for good X. Like
What do the green points, what do they show us?
how much we're buying that.
How much you're buying, exactly. So why are we doing this? Yeah, Dan?
it shows the marginal value of Y.
No. It may show lots of things, but yeah, Oli?
It shows the optimal points depending on which income you have. So it's showing that
Which price you're
which
facing.
price you're setting,
Yeah.
sorry. So it shows that at P1 you have a higher point and a higher indifference curve and a higher optimal point than you had at P3.
Okay, that's true. So let's do this. Look, I'm just going to take, so the picture right below this also has X on the horizontal axis. So it's right below this picture. It has the same scale, same X on the horizontal axis. But on the vertical axis, I'm just going to put price of X. And here's what I'll do. I'll take this first price, P1. That's the lowest one. And let's say this is P1. Okay. And then I'm going to say, at P1, how much does this consumer demand of X? This is how much. So I'll transfer that down to this picture right here. And I'm just going to note that at P1, this consumer demands this much of X, right? And then I'll do the same for P2. That's a higher price. So for P2, I'll say, okay, at that price, we know from this picture that that's how much the consumer demands. So I'm going to transfer that down here. At that price, that's exactly how much X this consumer consumes. And at this yet higher price, P3, I'm going to, again, take a look at how much the consumer in her optimal choice consumes of X and transfer it down to this picture. And just note that this is the quantity of X that this consumer consumes at that price P3. What am I doing?
Oh, demand curve.
Yeah. I just drew the demand curve, right? I'm drawing the demand curve. If you did that for every single price, you would have the demand curve. In fact, do you see if I were to start connecting these like that, it's actually shaping up to be a pretty good demand curve, right? So we derived, just very simply, this is really, really, we didn't need any math for this. We just said, let's create another graph right below the graph that shows optimal choice. And on the horizontal axis, let's just put the same scale of x. That's quantity of x. But on the vertical axis, let's put price of x. And let's change the price of x in this picture from P1 to P2 to P3 and see what happens to consumption of x. And let's just transfer that down to this picture. By doing that, just by doing that, you actually derived the demand curve for this consumer for x. So in a way, we are sort of done here. In a way, now you know. This is how demand comes from the optimal choice of the consumer, right? Do you have any questions at this point? Okay, so what do you think we need to know next? What would you want to do next?
Supply curve.
Well, okay, we'll get there. Yeah, we'll get there. But we have yet work to do here. What do you think we would want to know next? Yeah.
How to do it mathematically.
Yeah, I mean, this is fine. I mean, this is fine, and I think it's kind of fun because you see exactly what's happening here, right? This is really intuitive. I mean, you see how you change prices, and then you can just, on this lower graph, you can show exactly what happens to your optimal choice in X. That's your demand. It's really intuitive. It's really clear. But if you wanted a formula for that demand curve, you wouldn't get it from this, right? I mean, this is fun, but it's not going to give you a precise answer to how you actually derive demand. So that's pretty much what we would want to do. Because if you look at this picture here, this exactly corresponds to maximize utility subject to the budget constraint. This is it. And from that, we get the demand curve. So here, you could say, all right, I got one price. I'll solve. I'll find X. Then I'll take another price. I'll solve for that too. I'll get X again. I'll take the third price. I'll solve again. I'll get X again. The problem with that is that you have infinitely many prices to solve for, right? You have infinitely many prices you should check the solution for to get the demand curve precisely. And of course, okay, you know how to solve the consumer's problem mathematically, algebraically. You know how to maximize utility subject to a constraint, right? So presumably that should help you. That should help you find the demand curve. And I'm saying that to be able to somehow do this mathematically. Okay, so what we are looking for is your optimal choice in X, and you already know that, except for one thing. When we solved these kinds of problems in class before, I gave you a utility function. Like I told you what it is. I'm telling you here what it is. It's X times Y. So that's the utility function. I gave you an income. Here's your income. I gave you a price for Y, and I gave you a price for X. Now, if I did actually give you a specific number like 2 for the price of X, that would give you the optimal choice for that price. And of course, you could kind of want to do that. So instead, we just say price of X is P sub X. It's a variable. I'm not going to tell you what it is. It's not a number. We don't specify it. This is going to be a variable. We'll leave it as a variable. And when we get the answer, it's always a good idea to know what you're looking for as an answer, right? So the answer should look something like X equals, but X as a function of the price of X equals, right? Something. That's what we're looking for. We are looking for not a number for X. We are looking for what is the optimal choice in X as a function of the price. If we got that, that pretty much would be the demand curve. That would be the equation for demand. Okay, so I'll give you a minute just by yourself See if you can solve that. You might be able to, because you've done this many times, except px was not a variable. So the only difference is now px is a variable. See if you can solve the utility maximization problem with that utility function, that income, that price for y, and px as a variable. And see if you can actually find this demand equation yourself.
X over y? Is that it? You just stop there?
It can't be that, right? Because it should depend on x.
It does. Oh.
But it shouldn't. Well, no, I don't think that's the answer.
Okay.
He's working. I can hear he's working.
I
That's
know.
why.
So p x times p1 equals to 50. X times px equals to 50.
Yes, that might be. Okay, we are using two equations, right? We know that preferences are monotonic. Do you know that?
Yeah.
Because it's the utility function is x times y. And so you know that if you get more of x or more of y or more of both, your utility goes up. Okay, so we can just use the formula we have, which is the marginal utility, ratio of marginal utilities equals the ratio of prices. We use that, and if you solve for y, you simply get y equals px times x from there. Notice that when I substituted the prices, of course I left px as px because it's a variable. So that's one equation we use. What's the other equation?
Incoming equation.
Yeah, the budget constraint would be the other one. Okay, so with that, if you plug in the price of y, which is 1, and you plug in income, which is 100, and then you can, this is pretty simple math. You can simply take this. We have an equation for y and substitute it into here and solve. And you get 2 times px times x equals 100, and x equals 50 over px. And that's the demand function. That is the function we were looking for. That tells you for any price how much this consumer will consume of the good X. So take a minute and graph it right now, just roughly on a piece of paper. Graph that function for yourself. Okay, so show me what it looks like. Just draw it in the air. What does that demand curve look like? Yeah? Yes. Yeah, exactly. So the first thing you need to know, of course, is what goes on the axis. What goes on the horizontal axis?
Quantity.
Yeah, quantity of x, and we'll just use x. We usually use q, but we'll use x because now we are talking about specific goods that we call x and y. And on this axis, what do I have on the vertical axis?
Yes.
Price. So we have price, we have quantity, and it's going to look something like that. Okay? I mean, this is very rough, but essentially that's going to be about the shape. It's a 1 over x multiplied by 50. So that's going to be the shape of the demand curve. Okay, so now you have actually derived a demand curve. instead of saying, this is pretty significant, because instead of saying, we think it's intuitive that as you increase the price of a good, the consumer should consume less of it. Instead of saying that, we think it's intuitive. Instead of that, we say, we have a model for how this consumer makes choices. And according to that model, if the preferences of this consumer look like this, and if income is this, and if the price of the other good is this, then this is the demand curve for the consumer. And we're not saying that because it's intuitive. We're saying that because we derived it mathematically. All right, so you should be able to do this. I should tell you that deriving the demand curve is, in fact, I think not in the chapter in the textbook in chapter 4. I don't think that's in there. But I certainly expect you to be able to do it. So you should be able to derive a demand curve with Cobb-Douglas preferences, which is fairly simple, which we've worked with quite a bit by now, and with exactly this kind of setting problem. And I asked you, all right, but how would this demand curve change if I increase the price of Y? By the way, what do you think? If I change the price of Y to 2, how would this demand curve change? What do you think?
Lower.
You think? Let's use left and right. Would it go left or right?
Go left.
So if I increase the price of Y, you think this demand curve would shift to the left?
Yeah, it will shift to the left.
Right.
Left.
Some say left, some say right.
Left. Left. Left.
We are kind of stuck here.
Left. 1000% left.
Would anybody like to explain? Okay, so tell us why that.
It's almost like you will get the 3px equal to 100. 3pxx equal to 100. So which means about the 50 gonna be the less, you know what I'm saying? About the number over px gonna be less, so about the curve gonna be goes up.
Yeah, do you all agree? Shift to the left. Price of Y goes up, your demand for X decreases. Agree? Yes?
No.
You're not thinking, you're just...
You'd assume it.
If you agree, then explain why. Then tell me why. If you think that's true, then explain to me why. Okay? Okay, why don't you solve? This is easy, actually. You're solving in your head?
Yeah.
Right. Well, why don't we just solve quickly? This shouldn't be difficult because all you need to do is go through and change a few things. So why don't you all do it? Okay? Solve right now.
Oh.
No, you're wrong.
No, I'm wrong.
Yeah, so it goes to the right. Okay.
2y equal to
Yeah.
px, and which means y equal to half.
So I'll give you 30 seconds. Go through and change everything. The price of Y is now 2.
I just put this.
Solve for the demand curve
I know,
again,
yeah,
okay?
But it should be on the top. Yeah. I was like, how are you getting this book?
Yeah.
No, but you shouldn't think of it that way. You should think of it as well, think about look at the last equation. 2px equal 100. That 2px comes from the fact that 1 is equal to pxx, right?
So what's the formula?
So in this case, y was
The new demand function.
Demand function. Demand function should be
It's 200 over 3px.
3 over 200. I mean, sorry, 200 over 3px.
Okay, can you raise your hand if you have an answer? I'm just curious. All right, you'll need to practice this more, but I'll tell you right now. Actually, you will tell us, Mohammed.
So it's 200 over 3px.
You can go through and show what changed quickly, yeah.
So we're gonna put 2 here under px. So this is gonna be y is equal to px x over 2. And we're gonna substitute that here. Take the LCM, multiply 2 here. This is gonna be 3px plus pxx. So that's gonna be 3pxx, and this is gonna be 200. So we're gonna move 3 down there. So
Okay.
Divided by 3px.
Yeah, very good. So if we were to change the, thank you, if we were to change the price of y to 2, so if we double the price of y, we'll have a different demand curve. It's going to look something like that. And this is the demand curve d prime when the price of y is now 2. Right? Intuitively, tell me intuitively why is that very clear? Yeah.
Because when price for y would increase, there would be more demand for x.
Because
Price of y is more expensive than x. And to match the utility, you'll have to get more x.
okay, so y became more expensive, the demand for x should increase. That's the intuitive explanation. And the implicit assumption there is they are substitutes, right? You're implicitly assuming that. Okay, very good. But in fact, they pretty much are. I mean, if you look at the preferences, not perfect substitutes, they are not, but they are substitutes. Okay. Okay, so my point is, you know, we had to go through this whole thing to see what happens when you change the price of y, what happens to the demand for x. Wouldn't it? Okay. When we derived the demand curve in the previous problem, I actually told you what income is, and I actually told you what the price of the other good y is. Now, can't you imagine maybe an even more general demand curve, where even if I didn't tell you what the income level is, and what the price of y is, you would still be able to tell me, with that income and that price of y as variables as well, you should still be able to tell me what the demand for x would look like. And if you had that kind of demand function that is more general, you would be able to tell me how demand for x will change if I change income or if I change the price of y, for example. So if I asked you now, you know, if we went back to the far simpler, if we just solved for demand not just as a function of the price of x, but also as a function of the price of y, and as a function of income. And if anything changed, income or the price of the other good, or let's say the price of another good, or the own price of x, if any of those things change, we'll know what happens. We can tell exactly what happens to the demand for x. So that would be a far more general approach, and it's very well within our reach. All we need to do is, when we solve the utility maximization problem, we leave the price of x as a variable, but we also leave the price of y as a variable, and we leave income as a variable. And we are going to go even further than that. Instead of specifying the utility function exactly, we will find demand as a function of the price of x and the price of y and income for a whole class of utility functions, for all these Cobb-Douglas utility functions that have the form x to a, y to 1 minus a. That's a whole bunch of utility functions that we use a lot in economics, and they can be really simply specified. So we can just say we're raising x to some power and y to 1 minus that power. Okay, so you should be able to derive this yourself, but we'll go through it together. We are going to do exactly what you just did twice. We're going to do it a third time. But we'll leave prices and income as variables, and instead of a specific utility function, we'll use this general form Cobb-Douglas utility function. And when we are done, we should have an equation for demand that is far more general than anything you've seen in your economic studies so far. And it's going to, we're going to be able to get insight from that kind of general demand function much more easily than you would from a more specific, simpler demand function. So let's see how this goes. Essentially, as I said, we are doing exactly what we did before. So we start with the ratio of marginal utilities equals the ratio of prices. Okay, so the only thing that's different here is the math gets more messy. It's not more difficult, it's just more messy. All right, so this is the derivative of the utility function with respect to x. A times x to the a minus 1 times y to the 1 minus a. And then the derivative with respect to y, 1 minus a times we leave x to the a as it is, and then subtract 1 from the exponent for y. The good thing is, if you simplify that, you just have a over 1 minus a times y over x, which is one reason why it's so convenient to use these Cobb-Douglas utility functions. Okay? And that should be equal to the ratio of prices. All right, so we should be able to solve for x from there, right? And that's exactly what I have here. So solving for x, you get x equals a over 1 minus a times the ratio of prices times y. Actually, I hope you notice this is px over py. So here we have py over px, because when you solve for x, you need to multiply through by py and divide through by px. So we solve for one variable, x, in terms of the other variables, y, py, and px. And then we can use the second equation we have. So the second equation is the budget constraint. Price of x times x plus price of y times y equals income. And that's right here, except I already substituted x into the budget constraint. So we have this is x. We multiply that by price of x. And what happens is this price of x cancels. And what we are left with is a over 1 minus a times py times y. So this is price of x times x, except we substituted in what we got for x already. And then we add price of y times y. And that should equal income. So now we can solve for y. We have, by the way, we have how many variables? Well, we have x, we have y, we have price of x, we have price of y, we have income, but they are not all created equal. What are the two real variables in this problem? X and y. X and y are the real variables, because this consumer is optimizing by choosing x and y. Px, py, income, to the consumer, those are actually all given, right? So from the point of view of this consumer, those are fixed, those are given. From our point of view, we are not fixing them, because we want to see how demand would change as you change px, py, and income. So what you would say is those are parameters in this problem. X and y are really the variables. But those px, py, y, those are parameters, and we are leaving them as parameters so that we can see how demand will change when you change those parameters. Okay, so we are, and that's important to remember, because at this point, you might be a little confused, and you might think, well, maybe I found the solution. Maybe I wanted to solve for income. Or maybe, no, I haven't yet. Maybe I want to solve for the price of y. None of those. You want to solve for y because the consumer is maximizing by choosing x and y. Okay, so solve for y. And that's right here. So here you can just take out the y. This is fairly simple algebra, really. The only thing that makes it complicated is that we are instead of using numbers, we are using these variables or parameters. But other than that, it's just a linear equation in y, and you solve for y, and you get y equals income divided by price of y times a over 1 minus a plus 1. Now you can simplify that, because this a over 1 minus a plus 1, when you see something like that, you should be thinking, can I make that any simpler? And a over 1 minus a plus 1 is a over 1 minus a plus, plus 1 minus a divided by 1 minus a. And that is simply 1 over 1 minus a. Okay. So I get, instead of this mess, I can just take the 1 minus a up here, and I get 1 minus a times income divided by price of y. And that is the general Cobb-Douglas demand function. So now if I, okay, so we are not quite done, because that's y. What about x? So let's do that too, which is pretty easy by now, because we have a formula for x as a function of y. So all we need to do is take this solution for y and plug it in here. And if you do that and work through some messy but simple math, then you will get x equals a times income divided by price of x. So we have our solutions. We've solved for the two demand functions for x and y. There is something pretty interesting going on here, by the way. Look at that demand function for x. What happens? Well, we can ask a few questions. What happens if you increase income, for instance? Yeah.
would increase.
What would happen?
X would increase. Quantity would increase.
Quantity demanded would increase. What would happen to your demand for X?
It can be shifted to the right.
Would increase.
You're saying shift to the right.
Yeah.
Yeah? What do you all think? So you increase income, your demand for X. Can you see what's going on? If you were to graph that,
Yeah, it can.
it would shift to the right.
Yeah.
Okay. So now we can tell that, right? We can say that from just this equation right here. But there's something interesting. If I told you that the price of Y doubled,
Price of Y double.
price of Y doubled, what would happen to the demand for X?
It can be also shifted to the right.
Shift to the right? Yes? And how do we know from this equation? How do you know?
Because the I equal to the.
So income is a number.
Yeah, I mean I
It's-
equal to the px times x plus py times y. So right now the y goes
Well,
up.
no. You couldn't really do that because income is given. It's just a number.
The income is a number, which means it's constant.
Yeah.
So if you want two variable plus and be together and equal to the number, if y goes up, another has to be goes down.
Not quite, because I'm not changing income. I'm telling you we'll keep income the same, but we'll increase the price of Y. What will happen to the demand for X? Okay, let's vote. Shifts to the right, raise your hand. Shifts to the left, raise your hand. Nothing happens. Anyone? Okay, the answer is right in front of you, right here. So tell me what happens to the demand for X, Muhammad, if you double the price of Y.
So we don't have any y variable in our x formula, so it does not change any demand.
Exactly right. This has no py in it. It doesn't. Which means there's a little odd curiosity about this Cobb-Douglas utility function. And that odd curiosity is when you derive demand for X, it does not depend on the price of the other good. And the same for Y, which is unusual. Okay, so that's not a good thing. From my perspective, I wish it weren't that quite like that, because it would be maybe more educational if it did depend on the price of Y, the demand for X did. But we use this Cobb-Douglas form because it's really easy to work with it, and people use it in economics. So it's not just us here in this course or in this textbook, but people use it in economics. So there are some more general forms of a similar kind of utility function, but mathematically, it gets out of hand pretty quickly. So I wouldn't want to impose that on you at this point. Yeah, we just actually found something interesting, right? We derived demand for X and for Y for this Cobb-Douglas type utility function, and found that it so happens that with this form of preferences, the demand for X does not depend on the price of Y. And the demand for Y does not depend on the price of X. Okay. Yeah, do you have a question, Umar?
Last time we solved for Y, the step before
Yes.
solving for X, we solved for Y and then substituted that value into the function of X.
And then we substituted that into this function here, which we got before from the equation we started with. The ratio of marginal utilities equals the ratio of prices.
We start over the price doubling, won't the equation for Y change, and then when we substitute it into X. then-
So you don't want to believe that this is right. Am I right?
But I'm thinking, like, if we double the price, then that Y might change, right?
If you double the price of Y, then the demand for Y will change.
We're taking Y as a variable.
I mean, I just can't understand why you just can't go back for that. I mean, x equal to a over a 1 minus a times py over px, about that equation. No,
No.
I mean, at the bottom of the left, it should be the x equal to something about.
Like this?
Yes.
And?
Yeah, if you just focus on this thing
And then what? What do you want to do? So this is an equation. We derived it. It must be true.
no.
Okay,
there's
but what do you want to do? Okay. Think about it. All right, so think through this. This is something you will need to go through again at home, right, Ryan?
Alright, so for the utility maximizing function, the x to the a, y to the 1 minus it, can you use this even if the exponents don't add the 1? What if it was x to the a, y?
That's a good point. That's a very good point. So we are using Cobb-Douglas utility functions here, where the exponents add to 1. What would happen if they didn't? Have you seen anything like that before, where they don't add to 1?
You have to use the Lagrange method.
No, you don't. So those will still be monotonic. Have you seen anything like that, but the exponents don't add up to 1?
X and y.
Yeah, like 10 minutes ago, right? X times y would be an example. Yes, so that would be different. So maybe you want to solve that too. Maybe you want to figure out maybe you want to do that at home. Maybe you want to derive demand for the utility function x times y, but generally, not just, not for specific income and price of y, but for any income, any price of y, any price of x. Essentially, do exactly this. But here, instead of this, have x times y, and see what happens, okay? That could be interesting. That would be a good exercise.
Suppose A is almost told us what is the relationship between x and y, right?
So as a goes from 0 to 1, yeah, that changes the relationship between x and y. But in a very specific way, because in fact we know that your optimal choice of x will not really depend on the price of y, which means that there is a pretty specific relationship between those two. But I think Ryan's idea is good. Let's do this. At home, do the same thing. And I'm not blaming this on you, okay? I'm not blaming it on you. Let's do this for a utility function that says x times y instead of this. All right. So now we know how to derive demand graphically. We know how to derive demand mathematically. And that means maybe we can think through some of those first questions that I asked at the beginning of class that seems so intuitive, and maybe understand a little more about that intuition. Okay, so here's a very familiar picture. We have two goods, x and y, and preferences, and I'm showing you a price change. The price of x goes up. Okay? What happens in this picture? What happens to the demand for x? Yeah.
Decreases a little bit.
Seems like the demand for x goes from here to here. It decreases a little bit.
So what? I think it's increases.
But you see, in this picture it decreases,
No,
right?
it's not decreases. It's
Yeah, so in this picture it decreases, which is odd. At the beginning of the class you said, that would never happen. It's not intuitive. Yeah.
But I think the arrow was in the wrong direction between the budget line.
Oh, I'm sorry. So thank you. That's what you meant?
Yeah, I don't know
Okay.
what you're talking about.
Thank you. Now I see what you mean. So what I wanted to show you is, actually, let me think about that. Yeah, let's do that. Okay.
Price goes down.
So the price goes down. Price of x goes down. Okay, thank you. Now it makes sense, right? Price of x goes down, and yet the quantity demanded for x goes down. Okay. So at the beginning of class, you would have said, well, that's never going to happen. And you would have said it's never going to happen because it's not intuitive. And you would be right, it's not intuitive. But I'd like to try to get some insight into why it might happen anyway, because we see that theoretically it could happen. Right? We just actually, right here, you might say there are no such preferences. And I would say, yes, there are, and they are right here. I just drew it pretty easily, right? So these are real. These indifference curves, they don't cross. Okay, so I just drew preferences so that when you decrease the price of x, this consumer wants less of it. Okay, now to understand why that might be, we need to dig into what happens exactly when the price of a good changes. And the first exercise we did today, which was looking at a price change and then looking at an income change, actually gets us some insight. So our intuition for why you would want to consume, in this case, more of X, our first intuition was because X is relatively cheaper and Y is relatively more expensive. Therefore, you would want to consume more of X. That makes sense. Your intuition for the change in income was if income goes up, you would want to consume more of something, except, we realized, except when you have an inferior good, right? So if you have an inferior good, when your income goes up, you might actually want to consume less of it. It turns out that the explanation for this curiosity is exactly that. And here's why. When the price of X goes down, two things happen, actually. It looks like there's only one thing happening, but two things happen. Price of X goes down, X becomes relatively cheaper. That's true. But another thing happens. What do you think that is? If you're a consumer and you're consuming two goods, and in fact you're consuming quite a bit of this good X, right? And its price goes down. What does that mean? Yeah.
It changes your total possibilities as well.
You're able to.
Yeah.
It's almost like your income is larger.
Exactly. You'll feel richer. Okay, so let me put it like this. Suppose, we are in a different place and a different time, and your income is $100 a week, and you spend $80 on potatoes, because that's the only thing you can buy, because that's the food that you have, right? That's it, and it's really expensive. Okay, so you spend $80 of your $100 on potatoes. Now, suppose somebody invents this amazing new technology, and suddenly potatoes are abundant. And now, the price of potatoes suddenly is like 1/5 of what it used to be. Okay, let's say 1/4. So you could buy the same amount of potatoes for just $20, right? How does that make you feel? You see what I mean? That your point, exactly. Suddenly you feel like, oh, I have a lot of money now, right? And maybe before I would never have thought about buying meat or beer or anything like that. I would never have even thought about that. Because those $20, that went for all the other necessities that I had, right? But now I have a lot of money. So now I'm actually going to buy less potatoes than I used to. Because I'm spending all that, I'm spending just a tiny bit of my money to buy just a little bit of potatoes. And all the rest of that money is now going for other stuff. Okay? Yeah.
So we see that where it looks like the change in X, like the amount that X decreases is a lot less than the amount that Y increases, right?
Okay. That is true. And I would hesitate to attribute too much to those actual changes here, because all of this depends on my very bad artwork, right? So we don't want to depend on that too much. But what this means is, even though it looks like there's only one thing happening, there are two things happening. One is X became relatively cheaper. The other is your income sort of went up, right? Okay, so if we could break down this change into those two parts, we would get better insight into why this happens, or why it wouldn't happen, or when it would happen. So when our intuition is right, and when it's not right, and why it's not right when it's not right. Okay. All right, so to break it down, here's what we can do. We want to actually show those two different effects. So intuitively, we understand there are two different things happening. Let's actually show in this picture that there are two different things happening. So we'll break this change down. We'll break this change down into two parts. Instead of just this one pivot, we'll say, okay, first, part one, X becomes relatively cheaper. How can we show that? Well, the relative price is really the slope of the budget line, right? Mm-hmm. So when X becomes relatively cheaper, that means the budget line sort of tilts, and it's less steep, right? That's what it means. So we want to change that, but we don't want to increase your income. So what we mean is we don't want to make you feel richer. We want to change the ratio of prices without making you feel richer. And we can do that by saying, let's change the ratio of prices, let's change this budget line, but let's keep you just as happy as you were before. So we'll change the budget line to this gray one here. And this gray one is parallel to the new budget line because it has exactly the same ratio of prices. So it shows that X is relatively cheaper. Okay, so it has the different slope. But it's going to be still tangent to your original indifference curve. So that means with this new budget line, this gray one, it's not a real budget line. We are creating, this is an analytical tool. We are creating this. We are creating this to understand what happens here. So it has the slope of the budget line after the price change because it already shows that X is relatively cheaper. But it's keeping you exactly as happy as you were with that first budget line. So it's going to be tangent to this old original indifference curve right here. So if you wanted to imagine how you make that, you know, you would take this original budget line and you would tilt it to the right slope, and then you would move it up and down so that it's tangent to that original indifference curve. Okay, so we know, and then when we look at that, that should show us what the effect of X becoming relatively cheaper is. And we can see that actually right here. You know, it's pretty clear. So what's the effect of X becoming relatively cheaper?
You get more X.
You will get more of it. You know, that's what happens. And that's exactly what we would expect. So with that gray budget line that we created, that shows that X is relatively cheaper but keeps you as happy as you were before, so it doesn't make you feel richer, with that, your consumption of X would go up. Okay, but then there's a second effect, right? You feel richer because X is cheaper. How do we show that? Well, that's a change in income, essentially. So now we go from that gray budget line to this new budget line by just shifting up, right? That's simply a shift from here to here. It's a shift. What happens when you do that?
You get less X.
You go from here to here, right? So your consumption of X goes from here down to here. And these are the two effects. Now we actually see it analytically. We see it right there. These are the two effects that happen. And we have names for them. So this first part is called the substitution effect. So that is the substitution effect because intuitively X is relatively cheaper. So you substitute X for Y. X became relatively cheaper. The second effect is called the income effect. And the substitution effect always goes the same way. If you make a good relatively cheaper, more of it will be consumed. Always. That's the substitution effect. But the income effect can go one of two ways. For a normal good, you increase income, you consume more. But for an inferior good, you increase income, you might consume less. And if a good is really inferior, this income effect might be so large that it actually undoes that substitution effect and goes even further. And that's when you get this picture. That's exactly when you get this picture where you decrease the price of a good and yet consumption of that good, in fact, goes down. That kind of good, it's famous in economics because it's so curious, and it has a name. It's called a Giffen good. Okay, so this is a Giffen good, and now we know why a good may be a Giffen good, because it's so inferior that the income effect goes the opposite way of the substitution effect and completely overwhelms it. Now, as your book explains, you know, some economists will say you will never find such a good. I think my example with the potato would be sort of the example that you could think of. That's pretty much, you would need a good that is a big part of what you spend money on and is also an inferior good. Okay, so that's what we have time for today. We'll do more work with this after class, go through this again, do some of these exercises yourself again, and I'll see you tomorrow or Thursday.